Okay, so this is a set of notes on what we're going to call bisectors in triangles. Oops. Now, all totally, we're going to get what are called four centers of triangles, and you're going to get a thing called the circumcenter, an in-center, a centroid, and the orthocenter. The two that we're going to cover in this video is going to be the circumcenter and the in-center. The circumcenter relates to perpendicular bisectors, and the in-center relates to angle bisectors. Okay, so I'm going to move over to Geometry Sketchpad and get you a chance to see what this looks like and why they are important. Okay, so right now I'm in Sketchpad and I'm going to build a triangle. And given those four sides, I'm going to construct, or the three sides, I'm going to construct all their midpoints. So I just got the midpoints of all the sides of this triangle. For each of those midpoints and sides, I'm going to construct a perpendicular line, which means this is now a perpendicular bisector for that side. I'm going to construct one for this side, going through its midpoint. So that too is also a perpendicular bisector. Oops, that's too much. But this is now for that side. And I'm going to construct a perpendicular bisector also for this side. So there we go. And that one is also perpendicular and bisecting the side. Now you'll note that the point where they all lined up happened to land outside. Now if I were to drag this point and make this an acute triangle, if you look, it's an acute triangle. The point where they all line up lines in the inside. If I make it an obtuse triangle, the point lines up on the outside. So let's bring it into the inside, right? So okay, let me hide a couple extra points here so we don't have to see them. Don't need that one, don't need that one, don't need that one. And there we go. So this is the point that is connected to the three perpendicular bisectors. Now, what's interesting here is if I measure the distance from this point to any of the vertices, so that's from the center to that vertex is 3.93. From here to that vertex, oops, too much highlighted. Here to this vertex, also 3.93. And the distance from here to that vertex, also 3.93. So if I have this circumcenter, it is equally distant from all of the vertices of the triangle. And if you want to look at this, you can actually take and build a circle from there. So using the circumcenter as the center, and that circle will contain all three of the vertices. This is why we call this point the circumcenter. So it is the center of the circle that will go around the triangle. Alright, so that's my circumcenter. Let's start another slide and let's look at the in-center. So just like I did before, I'm going to build some arbitrary triangle, and now I'm going to construct the three angle bisectors. So I have to take it two at a time. If I take these two sides and bisect that angle, I get that one. If I take these two sides and bisect that angle, I get that one. And if I take these two sides and bisect that angle, I get that one. Okay, so kind of thinking about what we just did here, that is a bisector. So it's going to bisect that angle. This is also a bisector, so it's going to bisect that angle. And finally, this one down here is also, oops, we're moving the line, that's okay. Also a bisector. So, oops. Nope, that's not what I want. Real tiny in here. Well, not going to get what I want. But we also bisect this angle, right? So maybe we'll make this the 3 lines, so that way we know they're different, right? So I've got one bisector there, one bisector here, one bisector over there. Now, if I look, I again have this point in the center. Okay, so this one is what we call the in-center. Okay, and if I do a little bit of work here and start taking the measurement from that point to that line and construct or measure the distance between the point and the line, comes out as 2.62 centimeters from here to this line. So that's the perpendicular distance is also 2.62 centimeters, and this point to this line is going to be 2.62 centimeters. So where the circumcenter was equidistant from all the vertices, the in-center is equidistant from all of the sides of the triangle. And if you look at this, we can play the same game with the circle and put it right against each of the sides, and you'll see that it is tangent to this side here, tangent to this side over here, and tangent to this side there. So this center is the center of the circle that can be inside the triangle. So this is why we call it the in-center. Alright, so in a second here we're going to do a summary and kind of pull away what we can from the circum and the in-center. Okay, so we have a circumcenter. Oop. There we go. Runaway pen. Circumcenter. And we have an in-center. The circumcenter is where the 3 perpendicular bisectors intersect. The in-sector is where the 3 angle bisectors intersect. This is equally distant from all 3 vertices. This one is equally distant from all 3 sides. Alright, so there we go. This is what we need about the circumcenter and the in-center, and next time around we will get the centroid and the orthocenter.